This video was brought to you by the ILC. Hi there once again, welcome to episode 12. In this episode we're going to be solving a quadratic inequality that uses the not equal to sign. That's that sign right there. Now this is going to go a lot like the quadratic equations you've solved previously, but with a little extra dimension at the end after we've solved it. Let's get started. Alright, our equation today is 3x squared minus 8 is not equal to 2x squared plus 4x plus 4. Now, just like in a regular old quadratic equation, the first thing we want to do is get everything on the same side. Tends to make it a lot easier to solve. So let's go ahead and move everything that's on the right over to the left. We'll subtract the 2x squared from both sides. We will subtract the 4 from both sides, and we will subtract the 4x from both sides. On the right, everything will cancel out, and that should leave us with 0 on the right, like this. And now we'll just add our like terms on the left. 3x squared minus 2x squared gives us x squared. Then we have minus 4x. Forgot to write it the first time, I'll just fix it there. And then negative 8 minus 4 gives us negative 12. So this is a lot more manageable than what we started with. We'll go ahead and box it in. So once we've got everything on the same side, our next order of business is to try to factor it. Okay? So let's try to find factors of negative 12. Well, let's see. We could do negative 6 and positive 2. Because when you multiply those together, you do get negative 12. When you add them together, you get negative 4. Just so happens that is the number in the middle, so that is the right thing to use. So we're going to break it into our two parentheses, and we will have x minus 6 and x plus 2 as our pieces. Still not equal to 0. Alright, now that we have it factored, let's try to solve this and get what I'm going to call our points of interest. And by points of interest, I mean the places where the inequality becomes 0. That's going to make it a lot easier to solve this inequality if we know where it's 0. So if we have the left piece, we'll say x minus 6 equals 0. If we just move the negative 6 over, we'll end up with x equals 6 as our first point of interest. If we go to the other piece, we'll have x plus 2 equals 0. If we move the 2 over, we'll have x equals negative 2 as both of our points of interest. Now that we know what points we're interested in, the next thing we should do, anytime we have an inequality, your next step is usually going to be to draw a number line. It'll help us visualize the solution a little better. So I'm going to start by drawing my little arrows and my line in the middle. If you recall from earlier, our left-hand arrow stands for negative infinity, and our right-hand arrow stands for positive infinity. We'll go ahead and mark our points on the line. So we'll put 6 over here, negative 2 somewhere on the left. So now we've marked our points of interest. The next thing we should do is check what condition we're trying to satisfy with our inequality. So in our original equation here, the condition that was given right here is that it can not equal 0. That means our points of interest were where it became 0, so that means neither one of our points of interest here, the negative 2 or the 6, can be part of the solution. We're going to say no to both of those. So to show that we cannot include them, we will put an open circle in both positions. Make a note of that on the side. An open circle means it is not included in the answer. However, any number other than -2 and 6 is part of the solution. I'll outline everything else on the line in green, like this. Now, that -2 and that 6 are going to split the line into 3 regions. The first region over here between the negative infinity and -2, I'll call region A. This region in the middle between -2 and 6, I call region B. And between 6 and infinity, we have region C. So we can say that the answer is region A, and region B, and region C. Usually, when we're talking about sets of numbers like this, we put a little U in between each region, where U stands for union. They like you to do that anytime you're talking about sets of numbers. Well, the only thing left to do is say what region A, region B, and region C are. Now, region A is everything from -infinity to -2. So we write -infinity, comma, -2, and put parentheses around them like that. And then we say union. And then we carry on and say what region B is. That's -2 to 6, with parentheses around it. Union, and then say what region C is. 6 to infinity. And this is how we would write our answer. Got to put 3 sets of parentheses because we have 3 regions. So let's quickly recap what we've done here. We had a quadratic inequality, and anytime you have a quadratic, you want to first move everything to the same side. Once you've got everything on the same side, you factor just like you would any other quadratic problem. You solve each piece, and solving each piece gets you your points of interest. 6 and -2. We put our 6 and our -2 on the number line, and then we said the condition that satisfies this problem is that we can't equal 0. Okay? Since 6 and -2 make it equal to 0, they're not part of the solution, so we put an open circle for those and said the rest of the number line does satisfy it. Now, that -2 and 6 split the number line into 3 regions, A, B, and C, and so we had to write what A is, what B is, and what C is, separated by the union signs to give the correct answer. Well, that's all for this problem. In our next episode, we're going to show you how to solve other kinds of inequalities that use different signs. We'll see you then.